Welcome student in our channel Alchemy N. Today we are going to start modern periodic table and electronic configuration. If you remember, in the last period we have taken modern periodic table and its structure. Today new point we are going to discuss, that is modern periodic table and its electronic configuration. Okay. In the last period, you remember, we have seen vertical columns are there. Vertical columns are there. That vertical columns are called as group. And horizontal rows are there. Horizontal rows are there. That horizontal rows are periods. Even in the structure of modern periodic table, we have seen that 18 vertical columns are there, means 18 groups are present in the modern periodic table. In the modern periodic table, 7 horizontal rows are present, that we have seen. So keep in mind, 18 groups are there and 7 periods are there. On the basis of this valuable information, we are going to start today's our new point, that is modern periodic table and electronic configuration. So point number 1, groups and electronic configuration. Today's lecture we are going to divide into 2 points. Point number first, groups and electronic configuration. Point number second, periods and electronic configuration. Out of that first point we are going to start, that is groups and electronic configuration. Okay, so groups and electronic configuration. Point number 1, first let me tell you what is electronic configuration. If you remember, then also, suppose you are forgetting, then also let me tell you, electronic configuration is the distribution of electrons in different orbit of an atom. Electronic configuration is nothing but distribution of electrons in different orbits of an atom. So this is very first important point, which is related with the groups and electronic configuration, that is electronic configuration. You should know what is meant by electronic configuration. So it is the distribution of electron in different orbit of an atom. I hope this point is clear. Then point number second, related with the first point, that is groups and electronic configuration. Point number second, related with the groups and electronic configuration, that is valence electron in the group number first, that is equal to 1. In the group number first, how many elements are there? In the group number first, how many elements are there? In their last orbit, if we observe the electronic configuration of group number first element, in their outermost orbit of group number first element, they contain 1 electron. So valence electrons, number of valence electron in the group number first element, that is equal to 1. What is meant by valence electron? Let me tell you, the number of electrons are present in the last orbit of an atom. The number of electrons are present in the last orbit of an atom, that is known as valence electron. So point number second, related with the groups and electronic configuration, is valence electrons in the group number first, how many? 1. Okay, then valence electrons in the group number second, if we see valence electron, how many electrons are there, how many valence electrons are present in group number second element? So that is the 2. 2 valence electrons are present in the group number 2 elements. means in their atoms of elements. Point number 4, valence electron in the group number 17. If we observe group number 17, you know group number 17 is a group of halogen. In that, fluorine, chlorine, bromine, iodine, acetylene, like that elements are present. Out of that, we are going to consider fluorine, chlorine, bromine and iodine. These 4 elements are called as, combinedly called as group number 17, that is halogen. Okay, 10th standard we are going to see, we are going to consider halogen as a chlorine, a bromine, iodine and fluorine. Okay, so if we observe valence electrons in group number 17, so total valence electron in group number 17, that is equal to 7. 7 valence electrons are present in group number 17. For example, in chlorine, in the last orbit of chlorine, you will get 7 electrons are present. Okay, in bromine also, in iodine also. So valence electrons in the group number 17 element, that is equal to 7. And last point number 5, which is related with the groups and electronic configuration, is that point number 5, groups and electronic configuration. Point number 5 is that while going from top to bottom in any group, group number first, group number second, group number third, while going from top to bottom in any group, you can select group number first and you can go top to bottom in the first group. In any group, if we go from top to bottom, one thing we can observe. Which thing? While going from top to bottom of any group, one electronic shell is added. This is very important. In any group, if we go from top to bottom of that group, one electronic shell is added. This is very important point related with groups and electronic configuration. I will tell you, this is important notable observation related with the groups and electronic configuration. This is notable information. Suppose in the group number first, if we go from top to bottom, what you observe? After every element, one electronic shell is added. As we travel from top to bottom in group number first, one new electronic shell is added. Okay, this you have to keep in mind. Then point number 6, what is point number 6? Electronic configuration of outermost group. Okay, electronic configuration of outermost group is characteristic of particular group. This is important. Electronic configuration of outermost group means outermost group. Electronic configuration of outermost orbital. Okay, this is correct word. Electronic configuration of outermost orbital, because outermost orbital, how many electrons are present? That electrons we can call it as a valence electron. So electronic configuration, whose electronic configuration? Electronic configuration of outermost orbital is electronic configuration of last orbital of any atom. Electronic configuration of outermost orbital, electronic configuration of last orbital, outermost orbital of an atom is characteristic of particular group. Okay, that is the characteristic of particular group. That you have to keep in mind. Once again, let us discuss this point again. Electronic configuration of outermost orbit. Okay, electronic, whatever the electronic configuration of outermost orbit is the characteristic of that particular group. And point number 7, related with groups and electronic configuration, is that as we go down in the group, number of orbits are increases. That we have seen. As we go down in particular group, for example in group number first, as we go down, the number of orbits are increases. Group number second also, from first element up to last element. As we go down, the number of orbits are increases. Okay, I will tell you how number of orbits are increases. Let us take one example. What is the point? Let me remind you. As we go down in the group, in particular group, take example of group number first. Group number first, it is called as alkali metal. Okay, group number first, alkali metal. Short form, that is okay. Hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. Okay, these are the element: hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. These are the element which are present in the group number first. We have seen. Okay, you remember. So when we are going in the first group from hydrogen up to francium, hydrogen, then lithium, then sodium, then potassium, then rubidium, then cesium, then francium, what we have to observe? As we go down, hydrogen to lithium, lithium to sodium, sodium to potassium, potassium to rubidium, rubidium to cesium, cesium to francium. As we go down in the group number first, alkali metals, what we have to observe? Number of orbits or number of shells are increases. Let us see. Start example. Group number first, I told you. Okay, hydrogen. Hydrogen, one electron is present, one shell is there. After hydrogen, lithium metal is there. In lithium metal, two orbits are present. After lithium, sodium metal is there. In sodium metal, three shells are there. After sodium, potassium metal is there. In potassium metal, four shells are present. What you are observing? You are observing group number first element, hydrogen, one shell, one orbit. After hydrogen, lithium, then two shells are present. After lithium, sodium, three shells are present. After sodium, potassium, four shells are present. Then it increases in rubidium, cesium and francium by one. So this is important observation is that as we go down in the group, number of shells, that is orbit, number of shells or number of orbits are increases. So these 7 points are related with groups and electronic configuration. Hope student, you understood this point clearly. Okay, then as we discuss in the beginning of this session, that in this session we are going to discuss only 2 points, that is groups and electronic configuration. Now second point of today's session, that is periods and electronic configuration. Okay, periods are there, periods and electronic configuration. That point we are going to see, periods and electronic configuration. So let me remind you what is mean by period. Okay, period, if you remember periods are, that is horizontal rows are present in modern periodic table. Okay, if you remember, these horizontal rows are present, that is called as period. Okay, you remember. Then second point, let me tell you, periods and electronic configuration, that is the point number 1. Okay, periods and electronic configuration, that is point number 1. Under the periods and electronic configuration, which point we are going to study? Listen carefully. Periods you understood? No. Once again, let me remind you that in modern periodic table, horizontal rows are there. If you remember, let me ask you one question. How many periods are there? Your answer will be 7. Total 7 periods are there. Okay. Now you understand. Okay. In the modern periodic table, total 7 periods are there. This concept you can keep in front of your mind. Let us start. Period. Now we have to find out what is the relation of period and electronic configuration. Let us start. Total 5 points are there. Point number 1. In the period, from left to right, left of the modern periodic table and right of the modern periodic table. In the period, from left to right of the modern periodic table, first thing, atomic number increases by 1. If you go from in the period, now point is period and electronic configuration. Point number 1. In the period, if we travel from left to right, What you are observing? Atomic number increases by 1. What you are observing? What is your observation? In period from left to right, atomic number increases by 1. Okay? Let me tell you. First element in the period number second. First element lithium, atomic number 3. Okay. Second beryllium, atomic number 4. Atomic number increased by 1. Third element boron, atomic number 5. Atomic number increased by 1. Fourth element carbon, atomic number 6. Then nitrogen, atomic number 7. Then oxygen, atomic number 8. Then fluorine, atomic number 9. Then neon, atomic number 10. Lithium, atomic number 3. Beryllium, atomic number 4. Boron, atomic number 5. Carbon, atomic number 6. Nitrogen, atomic number 7. Oxygen, atomic number 8. Fluorine, atomic number 9. Neon, atomic number 10. These are the elements which are present in the period number second. You observe that as we go from lithium to neon, left hand side to right hand side, what you observe? Atomic number increases by 1. Hope you understand this point. Second point related with the periods and electronic configuration. What is that point? In the period from left to right, same. In the period from left to right of the modern periodic table, valence electron increases by 1. Okay. Valence electron, the electrons which are present in the outermost orbit, that is valence electron. You understand? You remember? In the period from left to right, valence electrons increases by 1. Valence electrons are increases by 1. Okay. Let me tell you. 3 example I will tell you. Now period number second. Once again we will take period number second. What we have to observe? In the period from left to right, valence electrons increases by 1. Okay, period number second. First example, lithium. Lithium atomic number 3. Electronic configuration 2, 1. So 1 electron is present in the outermost orbit of lithium. What we have to observe? Last electron increases by 1. So lithium 2, 1. In the last orbit, 1 electron is present. Second, after lithium, beryllium comes. Atomic number of beryllium, that is 4. Electronic configuration 2, 2. So in the last outermost orbit of beryllium, beryllium contains 2 electrons. Okay. So here lithium outermost orbit 1 electron, beryllium 2 electron, and one more example we will take boron. Atomic number of boron is 5. Its electronic configuration. Electronic configuration of boron is a 2, 3. Now see, lithium electronic configuration 2, 1. After that beryllium electronic configuration 2, 2, and boron 2, 3. What you observe? The number of electron in the last orbit, that is called as valence electron, increases by 1. Lithium 2, 1. Beryllium 2, 2. Boron 2, 3. Carbon 2, 4. Nitrogen 2, 5. So as we travel from left to right in the period, now here period example we have taken period number second, we observe that the number of electron increases by 1. So this is the second important observation. I hope you understand this example, this point what we are explaining with the help of example also you understand, and point also you understood. Point number third, which is related with the periods and electronic configuration. What is point number third? In the period, as we go from left to right, as we go from left hand side to the right hand side, number of shells means orbit. As we go from, in the period, this is important, in the period, as we go from left hand side to the right hand side, number of shells or number of orbits remains the same. In the period from left to right, number of shells remains the same. Okay. Point number 4. Let us consider period number 3. Now, let us consider period number 3. Previously, now just what we have discussed. Remember, we have discussed point number 3. In the period, as we travel from left to right, number of shells, number of orbit remain the same. Let us check that. Let us take example of period number 3 and let us confirm that number of orbit does not changes. Let us confirm. Period number 3, first element sodium, electronic configuration 2,8,1. Okay, 2,8,1. 3 orbits are present in the sodium. 3 orbits, 3 shells are present. Magnesium, electronic configuration 2,8,2. Again 3 shells, 3 orbits are present in magnesium. Aluminium, electronic configuration 2,8,3 in aluminium. Again 3 shells are there, 3 orbits are there. Silicon, electronic configuration 2,8,4. Again in case of silicon, 3 orbits are present, 3 shells are present. Phosphorus, in case of phosphorus, 3 shells are present. Electronic configuration 2,8,5. In phosphorus, 3 shells are present, 3 orbits are present. Then next, okay, with the help of this example, sodium, magnesium, aluminium, silicon, phosphorus, number of examples are there. With the help of this example, what we can observe, sodium 2,8,1, 3 orbits are there. Magnesium 2,8,2, again 3 orbits are there. Aluminium 2,8,3, again 3 orbitals are there. Silicon 2,8,4, again 3 orbitals are there. What we are observing in this period, important thing is that as we go from left to right, in the period, number of shell remains the same. With the help of sodium, magnesium, aluminium, silicon, this we have seen, and that is the proved. Okay, this is the proved example that in case of sodium, magnesium, aluminium, silicon, the number of orbits, the number of shells remains the same. With the help of period number 3 example, I have given the explanation. Now last point, shells and electron capacity. How many shells are present? Total 4 shells are present. K shell, K shell, L shell, K shell, L shell, M shell, N shell. Okay, listen carefully. Let me remind if some means mistakes will not be there. Total 4 orbits are there, 4 shells are there. First shell K shell, second shell L shell, third shell M shell, and fourth shell N shell. Now electronic accommodation capacity or electron accommodation capacity, that is called as simple word electron capacity. What is the electron capacity of K shell? The electron capacity of K shell is 2 electron. In K shell, maximum 2 electron can accommodate. Okay. Then what is the electron capacity of L shell? What is the electron capacity of L shell? Electron capacity of L shell is 8. Okay. Third one, electron capacity of M shell, M, capital M. Electron capacity of M shell is 18 electron. And last, electron capacity of N shell, capital N shell, is 32 electron. K shell 2 electron, L shell 8 electron, capacity of M shell 18 electron, and capacity of N shell 32 electrons. So here periods and electronic configuration, total 5 points we discuss. This point completes here. I hope in today's lecture we have completed groups and its electronic configuration, and second point, with the help of number of example, periods and their electronic configuration, we have completed. So it's a time to stop here. Again, in the new lecture, in the new video, we are going to meet. Please subscribe my channel Alchemy N. Keep watching Alchemy N. Thank you.